Now, I will do two types of circuits today. Okay, in the electricity chapter, yeah. There are many calculations. In the SPM, electricity is the biggest chapter. Okay, it's like you have like 40 questions of the MCQ, right? 1 to 40 ABC. From question 20 onwards to 40 is going to be all electricity. So it's a chapter that you cannot avoid. It's a big chapter, definitely it's going to come out. Okay, and it involves a lot of the calculations now. Right? So electricity and magnets, which we'll cover after electricity, is topic that every year definitely will come up in SPM. Okay. Now, first thing, 你要知道讲用这个人 V 等于 IR. Okay. So let's say I give you a resistor, and then there's current going through. Let's recall back a bit. What is current again? Current is electron flow. 你有 electron flow, 你就有 current. Okay, it's a flow of charge. So current is flowing through this resistor. When I say resistor, it's basically made of coil of wire. Think of it like a coil of wire, a few meters length. I make it into a coil and then let the current flow through it. The thing is that a wire carries resistance, something that slows down the current. Think of it like an obstacle. When the electron tries to flow, it's going to run into obstacles. That's going to slow it down. It's going to decrease the current. Resistance is something that decreases the current. Okay? So it comes from the wire, the particle in the wire. Here's the wire. This is inside the wire, okay? Inside the wire, you have a lot of particles, and then you have electron trying to flow past it. This is current. Basically, you have electron flowing with current. But as it flows, it's going to run into all these particles that are going to slow it down. That's where the resistance comes from. So the longer the wire, it is more likely to run into more collision, right? If I make the wire longer. So logically, if your wire is longer, you're going to have more resistance. Make sense, right? Logically, more wire, longer length is going to be more likely to run into collisions, so more resistance. So a resistor is I take a long wire, I coil it up, and then the current passes through it. So here, as it flows through it, it's going to run into collisions and hence resistance. Okay? So resistor, it has a resistance measured in ohm, omega. 2 ohm, 3 ohm, 4 ohm, okay, depending on how large the resistance is. The longer wire I use, the higher will be the resistance. Clear? Okay, we get the current down already and the resistance down already. Okay, now V is what? Voltage. Voltage is something that push the electron flowing. The electron doesn't just flow by itself. Something needs to push it. Is where the voltage comes from. Okay. Last time I said think of it like high ground and low ground. When you have a grounding difference, that's when the ball falls. If you have a level ground, the ball doesn't fall. It doesn't move from one point to one point. So that is the voltage, the ground difference. The higher the voltage, the higher the ground difference. Voltage has another name. It's called potential difference. Okay, voltage, potential difference. Right. So your VIR. Let's say I give you a resistor of 4 ohm. Current flow through 2 ampere. Amps is unit of current, just like kV is the unit of mass. Omega is the unit of resistance. What is the voltage across the resistor? Comes into this one. Your equation is VIR. So 2 into 4, 8 volts. This is 8 volts. That's it, right? So then your VIR, let's say I give you a resistor unknown. And then I say voltage across that, okay, 6 volt, current 2 amps. What is the resistance? Again, I use VIR. 3/5, 6 divided by 2, 3 ohm. Okay, straightforward, simple calculations. Now, the next thing is, when you get down this one already, we are going to apply it in the circuits. Okay, now let's construct a simple circuit. Simple circuits. You're going to have two types of series circuits. I take a battery, I take 3 resistors connected one after another, like this. Okay, let's say each of this is going to be 2 ohm. This I put it, okay, 3 volt. Do I have a complete path for the current flow? Yes. First thing is that you need to have a complete path. If there's a break in the circuit, then current cannot flow. Okay? There's no such thing as if there's a break here, the current flow to here and then stop flowing so that these two receive current. No such thing. It's either yes or no. You get current, everybody gets current, or everybody don't get current. So when there's a break in the circuit, when I make the switch here open, there's no current flow in the circuits. When I close the switch, okay, everybody gets current. Now, current comes out here, flow pass here, like this, come back. I want you to remember this rule of the series circuit. And this rule applies to all the calculations. The rule of current is I equals to I1 equals to I2 equals to I3. What does that mean? 意思是说，你的从 battery 出来的 current 是跟 flow through 第一个 resistor 的 current 一样 ，same as this one, same as this one. Current is the same everywhere in the series circuit. Why is it the same? Current 是 electron flow 对吗？如果我讲有5个 electron 走出来，到这边也是5个 electron 啊，到这边也是5个 electron 啊 ，it's the same path, there's just one path flow. Everywhere is going to be 5 electron. You cannot just say suddenly one electron disappeared. So current is the same everywhere. Number 2, voltage. Voltage of the battery is 3 volt. Voltage across the component. How many components I have? 3 components. All the voltage should add up to become the total. Remember I said voltage is something that push, like an energy. The battery gives 3 volt of energy. How many this one get, this one get, this one get, then divided. So voltage here plus this one is going to be equal to the total. V 等于 V1 加 V2 加 V3. So 3 volt, you can think of it like I have 1 volt here, I have 1 volt here, I have 1 volt here. So far so good? Yes? Okay. Third one, last one is resistance. Resistance, total resistance of 你的 circuit 就是这个加这个加这个 R total is R1 plus R2 plus R3. 直接把它加起来哦。如果你要的 total resistance, please remember all these 3 laws together with your P equal R. I will show you example how to use this for series circuits. Okay, we take down first, then we do one example. Okay, example. Calculate the current in the circuit. Now applying law of current for series. Is that a series circuit? There's just one path. Resistor is connected one after another. That is a series circuit. So this all three applies. Current in a series circuit is the same everywhere. Right. So how do we get the current in the circuit? We do VIR from this formula. When you want to calculate the current, you're going to need resistance and V. What resistance? You got 3 here. Now here's it. You want to be careful here. If this one, I want to find total current, this has to be total resistance, this has to be total voltage. Should correspond to one another. So what is the total voltage? 6. Total current, what is the total resistance? You need to first get it. How do you get it? What is the law of resistance in a series? Just add it all. Okay. So 2 plus 3 plus 4. 9. So IT 6 divided by 9. 2 over 3 is 0.67 amps. We got 0.67 comes up here. It's the same here, it's the same here, it's the same here. Calculate the voltage across each resistor. Across each one of them. So for resistor 1, I will do V1, I1, and R1. Current 我有了吗 ？Resistance 全部已经给我了，我也是知道 current 了。Then you can just get the beat. V1, I1, R1. This is 0.67 into 2. You get your V1. V2, I2, R2. 0.67 into 3. V3, I3, R3. Notice that all the voltages, you add it up, we should get 6. Okay. This one and this one, you get 6 because of the voltage law. individual voltages add up to become the total voltages. So this is an example using the to calculate. Okay, now last one. Calculate the current through the R3. What is current through R3? Current that flows through R3. 0.67. Current is the same temperature. This Saturday you guys will class one. 我们拜六有上课的，学校，你知道吗？就是其他的30，你们不对，你拜六有上课。But I thought you guys have class like chosen and class every weekend. Saturday, but this week, so you want to do tuition this Saturday? We discuss the exam paper. Next week I'm not going to be here. Because next week, the whole week I won't be in KK. So I'm thinking to bring the tuition to Saturday. If you can do it, if not, then we can do it afterwards. Yeah, you check your schedule first. Nên tôi bây giờ sang 3 điểm. Then cannot lah. Saturday is 12 minutes. 今天也是有 event 的是所以这个星期是练习的。比赛正热是拜六。Okay, second time. Series 是一个 half for another. Arrows you have multiple paths. So I make one path here. I branch out another two. The rules of parallel circuit, okay, current rule. Okay, 我们先看 current 先。Now, current 从 battery 出来 let's say 你有5个 electrons， right? 5 electron comes out. I total. Comes here, the first T junction, they will split. Some electron go here inside. This is I1. Let's say 1 electron go inside, but 4 go down. Another electron go inside here, another 2 electron go inside. I2. How many left you have? 2. 1 go here, 2 go here, 3 goes down. Sorry, 2 goes down. Okay, so this is I3. So the remaining goes here. The point is that this plus this will be equal to this. Okay, simple. Okay, easy to understand. I equals to I1 plus I2 plus I2. So current will split at the junctions. What about voltage? Voltage will be the same every single branch. Be the mid V1, the mid V2, mid V3。如果这个是battery 是6 volt， 每一个 branch 都会拿6 volt in a parallel circuits. Okay? So that's the good part, the good thing about parallel circuit is that everybody get the same amount of voltage. Now, 你的 series 是 terbalik 的，那你的 series 是 voltage 两加起来的，你的 series current 是一样的，它跟它标准超远。You to remember it. Okay, resistance. I'm just going to throw you a formula. 1 over R equals to 1 over R1 plus 2 plus R sun. Instead of adding straight away, which you do in series, you don't do it here. In a parallel, you do this. 1 over R. Okay, so show how to find it. Let's say I want to find the total resistance of this circuit. Calculate the effective resistance. Total, okay? So we do 1 over R, 1 over R1, 2 plus 1 over 2. 1 over 2 plus 4 plus 1 over 6. Okay, how much is this? So 8 over. Is that my answer? No. You see, the left hand side is 1 over R. You need to switch it. This one, you switch it, you get R over 1. This one, you have to switch also 12 over 11. So this is R equals to 12 over 11. Joule ohm 是你的 total resistance. Okay, effective resistance, the meaning is if I were to replace all these 3 resistors to a single resistance, what is the resistance going to be to give the same result? I repeat one more time. Effective resistance means if I were to replace all these 3 resistors to one single resistor, what is that resistor's resistance to give me the same effect as the 3 resistors. That's going to be 1.09. Meaning is, again, if I take this, I replace all these 3， 3个把它拿走，换成一个 resistance 是1.09的，这个 circuit 会给我一样的 current as 这一个 circuit. Okay, that is the meaning of effective resistance. It will give me the same result. Result means the current comes out. Same value of the current comes out. Can we calculate what value of current is this? Yes. Because we got this 6 volt. Okay, so that comes to B. Calculate the total current in the circuit. Okay? Total current in the circuit. So I'm going to do V equal IR. All this will be total. 6等于 IT， 然后 RT 是 1.09。5.50 ampere. Ampere. The same as here. Current comes up 5.50 ampere. Right? You put 3 resistors, it's gonna draw 5.56 current comes out. You put 1 resistor that has 1.09, it's gonna be equal to this. So we say that the effective resistance of this 3 is 1 ohm. Okay. 你算到的这个 5.50 this current is the total, right? Because we are using the total resistance. You give me the total current. It's not the current in this I1. It's not good. It is this one. Because you have to be careful. In the parallel, your current is not the same. Like a series. When it comes to C, calculate the current in each branch. Okay. Now, applying this, voltage is the same everywhere. So you know this is 6. You know this is 6. You know this is 6. Okay, it's the same number. So you want to get the current in branch I1. Do I have R1? Yes. B1? Yes. I1 equals to B1 equals R1. So VIR again. Okay, 6 divided by 2. 3 and I2. B2. with 3 amps, 1.5 and 1. What do you notice again? This one plus this one plus this one. The current in each branches add up, you get the total current. What is the current over here? Okay. 5.5 right? 5.5. Over here 5.5. So 如果你放你的 ammeter 在这一边，还有这一边 ，you are measuring the total current. If you put your ammeter in the branches, then you are measuring the current in that branches. Okay. Current here is current. Right, so that's the two types of circuits you have. Which one is better? What do you think? Series or parallel is better? See, if I do one series, 6 volt, 我放 OK， 2个 resistor 10 ohm 10 ohm. What is my effective resistance? Effective means total. What is my total resistance in that A, right? So you just add it. With the series that we just added. So total resistance is 8 ohm. Now, if I do it in parallel, the same resistor, exact same, but I arrange it differently. I arrange it in this. Still the same battery. Everything is. What is my effective resistance? Before you have to do this. Can you calculate what is your effective resistance? One over 4. Okay, you have to do the formula, right? 1 over R equals to 1 over 4 plus 1 over 4. That's 2 over 4. Right? But this is 1 over 2. Don't forget to switch this one. R is equal to 2. I want R, not the 1 over R. I want R. So you have to switch it back. Your R is 2 ohm. Compared to this one, this is 4 times of this one. If you connect the two resistors like this, you get 4 times resistance than the parallel one. Which one is better? Do you want high resistance or do you want low resistance? So you want low resistance. Why? Low resistance give you greater current. Resistance slows down current, reduce current. So if you change this one to bulb light bulbs, you connect light bulb in series, you're going to waste energy because you are taking so much resistance. You connect in parallel, you can amplify the current that you have. That's why all the light bulbs in the buildings are connected in parallel circuits. Okay, that's one thing. Not only that, in the parallel circuit you can control. If I put a switch here, I open this switch, there's a disconnect here. Can the current still flow? Current flow from here breaks. So this first bulb doesn't have current, but the current can flow down here. It has a complete circuit, right? The outer one has a complete circuit. So this second bulb lights up. This one goes off. In here, if you got one switch, you open the switch, everybody cuts off. No current. All the light. Or if one bulb is damaged, everybody's affected. That's the downside. Sometimes you see in a residential area, there's this power cut, the whole area goes out, no power. Sometimes you see there's one line of houses, there's power, another line, no power. This one no power. But this line got power because of the parallel circuits. Okay, the household circuits, how they are connected. Right, so that's the advantages and disadvantages of a series and parallel. In terms of resistance, this one is better because this one gives you lower resistance. So more current. So looks like parallel is the better one. Is there a downside to this one? This one you can control circuit each branch. You have lower resistance. Everything is like a good thing. Is there a disadvantage? Just one. It's complex. It's very difficult to build because you have to branch out circuits from here, branch out from there. It's complex, but overall, this one is the preferable one. Right, take a break. Wow, 真忙。
这个是明天还有这种，
明天要交啊？
对，
啊，有读本了。Okay, so for the online students, this is the example you can try. Now I straight away jump into the solution. Okay, for this one, what is this for? So calculate the current in the circuit before the switch one. You label the current flows in like this, and then come back like this. Okay, it doesn't go here because there's no connected path. So since current flow in the outer circuit, what is your effective resistance? Just like R effective. So ohm. And ohm I total, V total, R total is 6 divided by 12. 0.5 amps. What's the problem? Let that come back to you, okay? So 0.5. Did you get it? Okay. Oh. Okay. 0.5 amps. Calculate the voltage across resistor 4 ohm. You got already this one is 0.5 amps, same everywhere, right? So the voltage across 4 ohm is 0.5 times 4 ohm. That's it. 2 volt. Okay, see it? Calculate the current in the circuit when the switch is closed. Okay, how does it affect the circuit? 如果我关这个 switch， 它的 current， OK， 它的 current 到这边的时候它有2个选择。第一，它要选没有 resistance 的 path， 还是它会选有 resistance 的 path。 Which one do you think you choose? As a driver, you always want to take shortcut, right? So you will choose the one with the least resistance path. That means if you are given 2 paths, one has no resistance, another one got resistance, the current will always choose the one with no resistance. All of it, all of the current flow here. That means this will have no current. The current will go like this. Okay, so this is how it affects it. Only when your path has 0 resistance. 就是讲这个。如果你的 path 是有 resistance 的 1 ohm, if there is a resistance, the current will not all flow in one way. It will flow in 2 ways. It will flow here and here. Okay? Current will flow here. Some of the current go here, some of the current go here. Now you can guess more of the current will flow here. Why? Because you have 1 ohm less resistance, right? Less traffic, so more of the current will choose to go here. Less current will choose to go here. But if I remove the resistor such that I create a path of 0 resistance, 100% of the current will go there. There will be no current here. This we call it as a short circuit. You have heard of it, right? You may have heard of this word short circuit. People say short circuit, what does it mean? It means that the two wires accidentally touch each other. Then the current can straight away jump from one wire to another one, bypassing the electric circuit. That is a short circuit. It can result in a huge current spike and causes fire. Okay, fire. Especially when you have all the wires connected together, massive wire all bunched together, connected together, there's high chances of causing short circuits. Or maybe the wire outer layer, the insulator, the rubber layer, damaged already. It wears out already. So you can see inside, the wire touches and then you create a short circuit. Okay, it's the main reason causing fire in aircrafts, okay, in many electric places. Okay. So now we have a short circuit, the current go here, bypassing this one. Bypass, it doesn't flow through it. So just skip it. So what is your result? What is the overall effective resistance? Since current flow through this one and this one only, this one don't have. It's like as if it wasn't there, this one. Okay, so only this one. So your effective resistance will be reduced to 8 ohm. And then your current will be 0.75 amps. Right, so a short circuit will increase the current 0.75. Okay, I'll write an answer to this. For the first circuit is actually a parallel circuit. This is the same as, you can think of it like battery, and then I put the 4 ohm here. I put another 3 ohm. This is basically the same as this one. I just, instead of putting the battery here, I put the same thing here. So it's a parallel circuit. Now calculate the voltage of the battery. Voltage of the battery 意思说这个是 total voltage， 你要找的是 total voltage 对吗 ？V 等于 IR， 这个 total， 你首先要知道 total current which is 6 amps out of the battery is always the total current， 然后你要知道 total resistance， 这个要怎样找 ？Obviously you cannot find it from the same equation. You're gonna need another equation, right? 1 over R equal 1 over R1 plus 1 over R2. RE 1 over 4, 1 over 3. Okay, what is this? 7 over 12. So R is 12 over 7. 1.714 ohm. Okay, you got your effective already, your total resistance. Put it inside here. V 等于这个等于10点29 volts. Right, everybody got it, right? 10.29. Okay. B, calculate the current through each resistors. Now, I got the battery voltage already, 10.29. This is parallel, so same voltage here, same voltage here. Across the branches. Can I get the I? This I1. V1, R1. So we want you to see I2. So we want you to Okay. Question 4. How to do question 4? See question 12, it says wire has a length, has a resistance of 12 ohm, is bent to form a equilateral triangle. And then what is the effective resistance between P and Q? I bend it, overall the wire has a resistance of how much? 12 ohm, right? If you bend it into equilateral triangle, which is the same length, that means 4 ohm each. 4 ohm, 4 ohm, 4 ohm. The wire has a resistance. Okay, a better way you can think of it like you have a resistor here, 4 ohm. You have a resistor here, 4 ohm, and then you have a resistor here. Think of it like this. Okay? What is the effective resistance if I connect a wire at P2? Then connect. What is my effective resistance? How do you do this? Okay. These 3 points, you can choose which point you want to connect. Let's say I connect here to positive, connect here to negative. So my circuit goes like this. Positive, negative. Okay. What will be the effective resistance of my circuit? Where is your T junction? This is a T junction. A T junction is a point that has 3 branches. This is a T junction. This is not a T junction. This is a turning point. This is like taking a wire. I take a wire like this, and I just bend it like this. It's the same wire, right? The current flows from here to here. It's the same wire. From here to here is the same wire. But this one is different. This one you got another wire branch from here. So there's a separation. When the current flows, current separated. But for this one, the turning point, the wire just bend like this. Same current flow through. Current doesn't split. So that is the difference between a T junction and a turning point. Okay, a junction and a turning point. That means I can rewrite my circuit like this. This is a T junction, T. This is a T junction, Q. Here is your resistor, 4 ohm. This one, this is your battery, plus, minus. The 2 resistor is on the same wire. That means I can make my resistor here and here. This is 4 ohm, this is 4 ohm. Basically, it's the same as this one. I'm just redrawing the circuit like this. Because you are, in reality, it's just wire ma. On paper, the circuit draw like this rectangular shape, but in reality, it's actually the same wire. So it's the same to think of it like this. Okay. So what is this thing? What is this circuit? How do you get the effective resistance? Okay, these two, can you combine these two? They are in series, right? They are on the same branch. I can just add it, combine it, become what? 8 ohm. Then you have a 4 ohm under, and then like this. Plus minus PQ. You combine the two first, these two. Combine them already become 8. Then you can combine these two, the 8 and the 4. But you have to do it parallel. 1 over R equals 1 over A plus 1 over 4 over R. Sum over R. R over sum. Just 2.67 ohm. This is what I'm saying. The effective resistance 4 is the same resistance. So the equivalent power is 5. Let's P over P over R. I mean,